All right, so now we have another term we're going to call coterminal. And this again is important. And a lot of people get this mixed up with reference angles, so they're not the same. But let's talk about what a coterminal angle is. So let's say I start with my circle, any circle, it doesn't really matter. And I start here, and we're going to call this always, and we're just going to work in degrees first, because everybody always is a little more comfortable in degrees at the beginning. So I start there with 0 degrees, and I start moving in the positive direction around my circle, and I come all the way through, and I come all the way back to here. I come back to the exact same place. How far have I gone?
360.
I've gone 360 degrees, exactly. So we can say 0 and 360 degrees are exactly the same place, right? And I could do it again. I could add 360 more, and I could get 720 degrees. So all those are the same point. They're different values, but they're all exactly this point on the circle. That is called, those are called coterminal angles. So co, if you kind of means with, so they all have the same, they're all together, right? And terminal means end, so they all have the same ending spot. And that's true for this. They all have the same ending spot. So now let's say I'm here, and we'll call this, just say 50 degrees, right? So if I start at 50 degrees and I go all the way around the circle, what other angle is the same? It'd be 410.
410.
Because what we're doing is we're adding 360 to 50 degrees, right? And if I add that, if I add 360 to 50, I get 410. If I add 360 again, I get what, 770, I believe, and so on. So it doesn't matter where I am. I have these coterminal angles, and I can have them be negative as well. It can also be negative 360 degrees, because I could start here, go around my circle in the negative direction, which would make that negative 360. Okay, so that's what coterminal angles are. So how do we determine if two angles are coterminal? Well, there's a few ways. Do you have any ideas?
Maybe divide by 360, or
Yeah, we could. What we could do, I think for degrees, maybe the easiest way to do it is just kind of subtract them. So if we subtract 90 from 1170, I'm not using my calculator, so I hope I'm correct. Do you have a calculator in front of you, Alex, or you?
I have one over here. Yeah.
Okay, so you can check my numbers. I'm pretty decent with arithmetic, but I do make mistakes here or there. So that is 1080. The difference between those two is 1080. If I divide 1080 by 360, I get 3. Which, and I have there's no decimal, right?
No.
So that means these are coterminal, because to get from here, 90 degrees, to 1170, if I go around the circle 3 times, I'm in the exact same position. Okay, make sense?
Yep.
Okay, let's just do B real quick. And let's see what happens. So we have 844 minus 123, and we get 721, I believe. Yeah, I got it.
1, 2, 3, 7. Yep.
Okay, and then if I divide 721 by 360, well, I know 360 times 2 is 720. But notice I have this remainder of 1, which means these are not coterminal. They do not end in the same place. Okay, so now we want to talk about reference angles. And reference angles, I'm going to put the most emphasis on reference angles at this point, because they help us learn the unit circle. And when we get further down the line in trigonometry, they're going to help us a lot solve equations. So if you know your reference angles, you're going to be in good shape. So the values of the trigonometric functions of angles greater than 90 degrees or less than 0 can be determined from their values at corresponding acute angles called reference angles. Okay, so let's say, for example, and we've already done this, but we're going to do it again. So let's say I have this angle. We'll call it 30 degrees. Okay. I know if I take that 30-degree angle and I flip it over the y-axis, this value right here is still going to be 30 degrees. So reference angles are always from the terminal point. So this is our this right here is the terminal point to the x-axis. Very important, never the y-axis. If I actually use this angle to the y-axis, well, that's no longer 30 degrees, and I have a completely different triangle. So I can't use that. I have to use the one to the x-axis. I'm flipping these triangles over the x and y-axis. So, for example, this I know is 30 degrees, and this is 150 degrees, because I'm adding all this up and I'm going all the way from 0 to 150 degrees. I know this is 30 degrees because 150 plus 30 is 180, and it's 180 degrees to the left side or to the negative x-axis.
So you do it to the closest x-axis.
To the closest x-axis.
So the reference angle is 30, right? Degrees.
The reference angle is 30. It's always this angle. I'm going to write theta sub r, and theta sub r is going to be my reference angle. Okay. And if I were to say, okay, well, I'm going to put a point out here, I'm just going to do a different point. I'm going to put a point out here, and so if this is 180, this is 270 degrees, and this is 360 degrees, and this is 90 degrees, right? And let's say I pick a point, you pick a point between 180 and 270, any point, any value.
210.
210. Great. I have 210. So now I have an angle, it's 210. I know it's in the third quadrant because it's between 180 and 270. And I want to know what this value is, because that value is my reference angle, right? So I'm going to use something that I actually already know. I already know that if I go from here to here, how far have I gone?
180.
I've gone 180 degrees. And then if I continue on and I add my reference angle, right? So now I've also gone to here, right? Or I can say I've gone to here. I've gone to my 210. If I add these two together, these have to be 210 degrees, don't they?
Yes.
Which helps me know if I solve for the reference angle, my reference angle is 30 degrees there. So what does that mean? Well, I already know everything I need to know about the angle in quadrant 1 that's 30 degrees, because I've memorized it, or I've learned it however I've learned it. And I know that point is the same as the square root of 3 over 2 1/2. So that means at 210, my values have got to be, well, they're the exact same length. So, but they're in quadrant 3, so they're both negative. So did I have to actually memorize the point that goes with 210? No, I just had to know what the reference angle was. And the reference angle is always going to reference quadrant 1, reference angles are always positive and between 0 and 90 degrees. 90 degrees, or in radians, between 0 radians and pi over 2 radians, because that's quadrant 1. We're using reference angles because we're referencing back to quadrant 1. Whatever quadrant we're in, we're always going to reference back to quadrant 1.
What if quadrant 1 isn't the closest?
It doesn't matter, because all my answers are always going to be between 0 and, like here, what was my answer? 30 degrees, wasn't it, for my reference angle?
Yeah.
And 30 degrees is in quadrant 1.
Oh, okay, I see what you mean. I see.
So always the reference angle. It doesn't matter if I'm in quadrant 4. Let's say I pick a point in quadrant 4, and I'll call this 290 degrees. Well, that can't be my reference angle. It is positive, but it's not between 0 and 90, right?
Mm-hmm.
What can I do to find my reference angle? My reference angle is always going to connect my terminal side to my closest x-axis, right?
Mm-hmm.
This is my reference angle if I'm in quadrant 4. So what do I do?
360 minus 290.
Right. Here, let me erase this so I can explain better. So I know if I start at 0 and I go all the way around here, I'm going all the way around to here, that's 290. So I have 290, again, plus my reference angle, because that's the piece here that I'm adding. This is my reference angle. That's got to equal 360 degrees, which means my reference angle is going to be here, 70 degrees. And 70 degrees is, again, positive. So good, it's positive. And it's between 0 and 90 degrees. I now know for sure it's my reference angle because I did it and then I checked to make sure it's positive. And 70 degrees is in quadrant 1, so that is my reference angle. Here are like little equations that they tell you. I don't really like memorizing things, so I wouldn't recommend it, but you can do whatever you want. So let's say my value ends up in quadrant 2. And in quadrant 2, let's say that's 120 degrees, which is in quadrant 2 because this is 90 and this is 180. So it's got to be between 90 and 180. It means I know that from here to here is 120 degrees. Here's my reference angle. It's connecting my terminal side to my closest x-axis. And what I really want to know is, what is this angle, right? This angle right here. Well, I know that 120 plus my reference angle is equal to 180. So my reference angle is going to equal 60 degrees. And that's what all these formulas are down here. And I'm going to show you how to do it with radians as well. But so far we're working with degrees just so you get a good idea of what a reference angle is. So hopefully now you have a pretty good idea of what a reference angle is. Let's say we have these values on our circle. And I'll just draw a circle out here. We start with theta equals 300 degrees. I know this is 0 degrees. I know this is 90 degrees. I know this is 180 degrees. And I know this is 270 degrees. What quadrant would A turn out to be? 300 degrees is in quadrant?
4.
Quadrant 4. So I'm just going to put a line in quadrant 4. And my reference angle always connects my terminal side to my x axis. That is my reference angle. And I know that if I go all the way from here to here, I've gone 300 degrees. I know this is 0, but I also know this is the same as 360 because it's a coterminal angle. So what can I say here my reference angle is? 60 degrees, exactly. And I'm just going to write here, theta sub r equals 60 degrees because 300 plus 60 gets me all the way back to 360. So that took care of that one. How about negative 135 degrees? Well, we haven't really done a lot with negative values, but let's do it. So if I start here at 0 and I go in the negative direction, don't forget I go this way, that's the negative direction. This would be the same as negative 90 degrees. This would be the same as negative 180 degrees. And this would be the same as negative 270 degrees. And again, we can say this is the same as negative 360 degrees. It doesn't matter, right? If I want to go negative 135 degrees, what quadrant would I end up in?
3.
I would end up in quadrant 3. From here to here is negative 135 degrees. And what I want to know still, since this is the terminal side, I want to know what that value is that connects the terminal side to the closest x-axis. What can I do here to find that value? Any ideas?
I did 180 minus 135.
180 minus 135. Very good, which gives us 45 degrees, right? This is 45 degrees. If you did negative 180 minus 135, you would get negative 45 degrees, which is still okay. Just remember, reference angles are always positive. Take the absolute value and you would still get 45 degrees. The reference angle for minus 135 is 45 degrees.